Assume that the time between arrivals of customers at a particular bank is exponentially distributed with a mean of 4 minutes. So before we actually look at the questions, let's just think about what we're told. We're told that mu is equal to 4 minutes. The other thing that we would know, remark upon, is that there's another thing called lambda, and lambda is the rate parameter, and it's also quite important. So lambda is the rate parameter. It's equal to 1 over mu, and that is equal to 1 over 4. Okay. Now, additionally, just to you might spot it down here at the end of the page, this is actually the same equation in reverse. Mu equals 1 over lambda. So the rate parameter lambda and the mean mu are inverse and are reciprocals of each other. Okay, that's just an important step. Now the reason is because sometimes here is a formula from the back of the exam paper, and in this particular case it's actually given in terms of mu. But in other cases, that might be given in terms of lambda. And when so the equivalent expression for the top one, you might sometimes see this instead, minus k lambda. Okay, that's the reason why it's important to mention both mu and lambda. Okay, so again, the two expressions are directly equivalent to each other. Just a slight change of notation. Okay, so that's important. So find the probability that time between arrivals is greater than 5 minutes. Okay, well, let's just look at this here again. We're told that the probability of x less than or equal to k. X is the time between arrivals, capital X, time between arrivals. That's what it means. And what is the probability of x greater than or equal to 5? Okay, that's what we're asked here in this question. X greater than or equal to 5. Now we can use this formula here, probability of x less than or equal to k, and just find the reciprocal, or the complement of that. So here you have it up here again. So the probability of x less than or equal to 5, let's just work that one out first. We're going to use the top formula here. As long as k is greater than or equal to 0, yeah, k is greater than or equal to 0, it's 5, so we can use that one. That is 1 minus e to the power of minus 5, k is 5, divided by 4. Okay. Just as a remark, if you were doing that lambda, k times lambda, you actually get the exact same thing right there. Okay. So this is just a little bit of calculation work now. So that's equal to 1 minus the exponential of minus 1.25. Calculator. And that is equal to 1 minus 0.2865. And that is equal to 0.7135. Okay. So that is the probability of x less than or equal to 5. The complement of that, probability of x greater than or equal to 5, equals 1 minus 0.7135, and that is equal to 0.2865. I've actually done it the long way here. I've deliberately done it a long way just to sort of show you something, that this is actually equal to e to the power of minus k over lambda. So in general, this is not actually given in the formula, but it's actually the idea of the complement rule, that the reason wasn't given is like if you're reasonably wise to it, you can actually say this directly, that the probability of x greater than or equal to k is e to the power of minus k over lambda, or actually just using the alternative notation, k divided by mu, or k times lambda. So the answer to the first one there is 0.2865. Okay. Find the probability that the time between arrivals is between 1 minute and 4 minutes. Okay. So let's break this up first into two parts. So probability, let's actually just write that out, what we're being asked here. So it's between 1 minute and 4 minutes. So the probability of x being between 1 and 4. Okay. So this is an interval probability. And what I'm going to do here is use the too high, too low approach. So the probability of being inside an interval, like we have up there, is 1 minus the probability of being outside the interval. And if you're outside the interval, you're either too high to be outside the or too low. So that's equal to 1 minus the joint probability of too high plus the probability of too low. It's a very simple but perfectly logically robust way of doing things. So that is equal to, what's the probability being too high? 1 minus probability of too high, here it is 4 minutes, x greater than equal to 4, and the probability being too low is less than 1. So the plus the probability of x less than or equal to 1. So what we have to do here is calculate both of these, add them together, and subtract from 1. So probability of x being greater than equal to 4, that is equal to, I'm actually going to use that expression there I used previously, that is equal to the probability of minus 4 divided by 4. That's the exponential of minus 1 e to the power of minus 1, and that is equal to, let's just check my calculator, 0.3678. Now, the probability of x less than or equal to 1, that is equal to 1 minus the exponential of 1 divided by 4. Again, using this formula up here. Actually, I'll just sort of be clear again with regards to the first one there, that the probability of x being greater than k is just e to the power of minus k over mu. Okay, so it's the complement. These two expressions are the complements of each other. This expression here and this expression here. So it's just something I mentioned a few minutes ago, but just again to repeat it. This is equal to the exponential of minus 0.25. That again is a bit of calculator work, and that works out to be 0.7788. So it is 1 minus 0.7788, and that is equal to 0.2112. Sorry, 2212. Okay. So the probability of being outside the interval is the sum of those two together, and that is equal to 0.5890. So the probability of being inside the interval is equal to 1 minus probability of being outside, 0.5890, and that is equal to 0.4110. So the probability, let's write it here now, the probability of being between 1 and 4 equals 0.4110. So that ends this presentation on the exponential distribution.